Let's have a look at example 2. Mr. Farmer buys machinery for $25,000. The machinery depreciates at a rate of 8% per annum. A, find the value of the machinery after 5 years. B, find how many years it is before Mr. Farmer's machinery is worth half its original value. Now, this is a very typical type of question, and in example 1, I was talking about how you must be careful when you're dealing in years, especially when you have a situation where the value changes during the 1 year. So in the first year, it's 25,000. If you assume that's January the 1st, by the end of the first year, it's going to be 25,000 less 8%. All right, now I'm going to do this a little bit differently than what they've done here. Okay, you notice you've got a 5 up here. Well, if it says after 5 years, why aren't you seeing a 4 up here? Because we know the formula is n minus 1. I think it's easier to go back to the first principles of this and have a look at it. It's only over 5 years, so we can have a look at it year by year. Let's do that first, shall we? Okay, so we'll all agree that let's assume this is at the beginning of the year. Okay, after the end of the first year, its value is 25,000 times 0.92. Okay, let's write that out. So it's going to be 25,000 times there's 0.92. That's because it's, well, we'll put it in, it's 1 minus 0.08. Okay, and that gives us a value of 25,000 times 0.92. So that's the end of the first year. Find the value of the machinery after 5 years. So after 5 years, that would be at the end of the 5th year. That's the end of the first year. Okay, let's use this as U1, and we'll call 25,000 U0. Let's call this U1. Okay, so we've got 25,000 times 0.92. Okay, that's U1. That's the end of the first year. Then in the bracket, we have to put the factor, okay, the actual ratio there, R. Now, in this case, it's 0.92. Now, we know by the formula that we should put up here n minus 1. Okay, so that's why I'm going to put a 4 up there. Now, be careful. It's a little bit different than here. They've got a 5, right? I'm going to put a 4 up here because I'm saying at the end of the first year, it's this. So that's U1. At the end of the 5th year, it's going to be 5 minus 1 up here. So I'm going to put 4. Okay, now just compare that to this. We've still got 5 of them because we've got an extra one here. So if I was to rewrite that, I could still have exactly what's here. 25,000 times 0.92 to the 5th. Remember, if the bases are the same, you add the indices. So that's 4 plus 1 is 5. So that's equivalent to 25,000 times 0.92 to the 5th. And that's in the 5th year. Okay, so we've got the same. And we should come up with that same answer. Okay, so that's A. Let's have a look at B. Now this is interesting, and I think this can get confusing. When you've got an n here, even though prior to this we've been told that should be n minus 1. As we've seen up here, they actually used n here. If it's 5 years, they put n is 5. But we learned it should be 5 minus 1. So you really have to understand what's happening in the situation here. Half of the original value is 12,500. Okay, so let's go back here. So, okay, it's worth half its original value. That means that our left-hand side, we'll put that down as the left-hand side, is going to be 12,500. Let's write that in, shall we? So for B, got 12,500 equals. Now the question is how many years? So that's going to be our n. Okay. So I'm still going to use U1 as 25, which is different from their explanation. 25 times 0.92. That's my U1. In here, I'm going to still put R, And here I'm going to put n minus 1. Okay. Now, I think it's true that this is a little bit easier to solve because it's got n and we've got n minus 1. But it's not hard to deal with that. Okay. So let's deal with it now. So we've got here, I'm going to shift these two here. Well, I'll shift that one over to here first. So we're going to have 12, 5. And if you will allow me to put 125 over 250, you just knock off the 2 zeros. Okay, we see that looks like 1/2. That equals 0.92. Now remember, I can rewrite this as 0.92 to the n divided by 0.92. Because I'll just rewrite that. If remember from the laws of indices here, I can rewrite that as 0.92 to the n times 0.92 to the minus 1, which is equal to 0.92 times 0.92 to the n divided by, and that's all divided by 0.92. Now this and this are going to cancel. And what we've left is a half equals 0.92 to the n. Okay, so that's actually what we've got here. So we do end up with the same, but we're true to the formula here. If you rewrite that, it's going to be 0.92 to the n equals 12,500 divided by 25,000, which is a half. So that's true. Now they say using your solver, and you should use the calculator solve function, but we can also use logs. So why don't we use logs? Okay, because that's a 2, I'm going to use log 2 on both sides. Log 2 of a half. Half can be written as 2 to the minus 1. That equals n log 2 of 0.92. Now, log to the base of the same number there equals 1. So this actually equals 1. We can bring down the indice to here. So I'm going to put minus 1 equals. Now the reason I've made that step, because I bring the minus 1 to the front, and log 2 of 2 is 1. Log 3 of 3 is 1. Log 4 of 4 is 1. So minus 1 equals n times that number, log 2 of 0.2. Log 2 of 0.92. And that implies that n equals 8.31. Okay, 8.31. It's actually 8.3129504 in the IB exams. We use 3 significant figures, so we're going to put it at 8.31. Years. Okay, make sure you write years in. And that's the answer there. So let's just write years, shall we? Years. Okay, great. Good example, that. Very typical question.